So the next we will discuss is the chlorine and the caustic soda. So here, as we have discussed earlier, the chlorine and caustic soda, they will be produced in a single unit. So in the electrolytic cells, we get the chlorine at one electrode and we get the caustic soda at the other electrode. So these two chemicals are being discussed in combination as they are produced as the co-products in the electrolysis of the brine. Then if you see the properties of chlorine, it has molecular weight of 70.9. The melting point is minus 101.6 degrees Celsius. Then boiling point is minus 34.6 degrees Celsius. Then it has a critical temperature of 146 degrees Celsius and critical pressure of 93.5 atmospheres. Then the liquefaction point is 5.7 atmosphere and 15 degrees centigrade. Then toxic gas 0.35 to 2 ppm is the maximum concentration. So above which we can have the lethal damage. Then technical grade is 99% of chlorine. The same way if you see the sodium hydroxide properties, so molecular weight is 40 and the boiling point the 1390 degrees centigrade. Then melting point is 318 degrees Celsius. It is very soluble in water with high exothermic heat of solution. So whenever we are dissolving sodium hydroxide in water, you can feel the heat is evolving. That is the heat of the solution. Then the grades, it's available in solid form of flakes, granules, sticks, lumps, pellets and aqueous solution of 50% or 73%. Then purity of solid form ranges from 60% of Na2O, that is 77.4% of NaOH, to 76% of Na2O, that is 98% of sodium hydroxide. If is the end users of this one, then we can use in pulp and paper industry, then we can use for the PVC manufacture, that is polyvinyl chloride. Then we can have the chlorinated paraffin wax. Then inorganic chemicals manufacturing, organic chemicals manufacturing, we can use major in pesticide and insecticide manufacturing. We can use for the water treatment where the chlorine is or bleaching powder we are adding to remove the bacteria. Then we can use in pharmaceuticals to produce drugs, and we can use the sodium hydroxide in rayon grade wood pulp to dissolve the wood. Then there are various methods of production of chlorine and the caustic soda. So electrolytic process producing the chlorine, sodium hydroxide and the hydrogen as co-products, and it's account from 80% of production. So in this also we have the different electrolytic cells. So first one is diaphragm electrolytic cells. So it uses saturated brine solution and produces 10 to 12% of caustic, which must be concentrated by the evaporation of the water, and it is being replaced by the membrane cells nowadays. Then mercury electrolytic cells, it uses the saturated brine solution with solid salt makeup and gives about 70% of caustic directly. So in diaphragm we get very less concentration, whereas in mercury we get the higher percentage of caustic soda. Then the chlorine process without co-products. So here we will have the HCl air oxidation with Fe2O3 catalyst, then HCl air Cl2 oxychlorination processes. So example, production of ethylene dichloride from ethylene, then nitric and NaCl air process. So the next one is NaOH process with no Cl2 co-products. So you can see sodium carbonate, the calcium hydroxide. So no further investment allocated as process not competitive. So this is not used in nowadays. So in electrolytic cell process if you see, so we have discussed the diaphragm cells, then mercury cells, and the next one was the membrane cells, so that which is replaced the diaphragm. So here you can see the anode and the cathode. So in electrolysis the negative ions which will go to the anode, whereas the positive will go to the cathode. So what happens over here, the calcium ion will go over here as a Cn minus, and the NH plus they will go to the cathode being negatively charged. So here the Na plus ions, they will react with the water and they will give the NaOH in aqueous grade, whereas Cl minus it will lose the electron and will give the chlorine as a gas at the anode side. So if you see the anode, mainly the electron loses, means it will give the oxidation reaction over here. So the chloride ion which loses a electron and gives Cl 0, and which Cl plus Cl, it gives the Cl2 as a gas. Then as the cathode which is negatively charged, so positive ion will be attracted toward it. So Na plus with the reaction of water and adds the electron. So reduction reaction will takes place. So here the Na plus and the OH plus, they will combine to give the sodium hydroxide with the evaluation of the hydrogen. So that will be burned and it will form the water again. Then if you see the overall reaction, then NaCl and H2O gives the sodium hydroxide, then hydrogen and the Cl2. So we have to, so delta H here will be the positive, so plus 53.4 kilocalorie per mole of the product. So here we have to give the electric energy in order to have the electrolysis. If it is the mercury cell, so in mercury cell we are using the NaHg, that is sodium amalgam. So same thing happen over here. So here what happens, the anode, the chlorine gas will be evolved, whereas here the Na plus ion will be attracted. So if you see at the anode, the chlorine ion, they are reducing and they are forming the chlorine as a gas. Whereas the cathode, Na plus going to reduction. So by reducing of the sodium, we get the Na without charge. Then this will react with the mercury, which gives the amalgam. And then denuding, though the sodium amalgam, when reacted with water, gives the sodium hydroxide with the evaluation of hydrogen, and we get the mercury back. And if you see the overall reaction, then NaCl with water gives the sodium hydroxide, then hydrogen and the Cl2. So only difference between diaphragm and this one, that we have the sodium amalgam over here in the mercury cell. So here if you see the raw materials, so principal raw material is purified brine, solution of 10 to 50% of NaCl or the solid salt, depending on the type of the electrolytic cell used. So you have to go for the brine solution which have 10 to 50% of NaCl dissolved in it, or we can have the solid NaCl which we can dissolve in water to get the required percentage of NaCl in water. Then minor quantities of sodium carbonate and sodium hydroxide for salt purification and the sulfuric acid for the chlorine drying are required. So here we are using the sodium carbonate and NaOH in order to purify the salt. So whatever the impurities that will be purified by using this one, and also the whatever the chlorine gas we are getting, that will be aqueous, so that we can dry by the use of the sulfuric acid. So it will remove the moisture from the chlorine, and we can ship the chlorine without moisture and in a purified quantity. So the quantity requirements for this being, so if we are producing 1 ton of Cl2, 1.15 ton of the sodium hydroxide, which is 98% pure, and 283 Newton meter cube of the hydrogen, that is around 26 kg, if we are producing in electrolysis cell, then we require salt 1.3 tons, then we require soda ash 58% of Na2O to purify the salts, it's 26 kg. We require sulfuric acid, that is 98% of 5 to 6 kg to remove the moisture from chlorine. Then sodium hydroxide, again to purify the salt, it's 10 to 15 kg. Then graphite and mercury we needed to run the electrolysis cell. Then steam, it's 11 tons for diaphragm cell process. Then electricity consumption in electrolysis process is around 2900 kilowatt hour. And the plant capacities, they will vary from 100 to 1000 tons a day of Cl2 in a series of electricity units, each producing 0.5 to tons of Cl2 per day. So what happens in the diaphragm cells? So diaphragm and the mercury, if we discuss, then brine solution is filtered to remove the impurities like the calcium and the magnesium ions, and also the iron salt which would clog the diaphragm. So this need to be purified earlier before sending to the electrolysis cells. Then saturated brine solution of 25 to 28% of NaCl is heated and neutralized in a diaphragm cells. So earlier we have discussed the reaction was the endothermic, so we need to provide heat to it. Then cell operating at 45 to 55% decomposition efficiency, then discharges 10 to 20% solution of sodium hydroxide with about equal concentration of sodium chloride. Then the multiple effects evaporation to concentrate NaOH solution. So whatever the solution here getting, that is 10 to 12%. So we can make it stronger by concentrating over the evaporators. So multiple effect evaporators that may lead to the concentration more than 50% of NaOH. Then the salt precipitated is separated, centrifuged, washed and then served with the treated brine. So here whatever the NaCl we are getting, we can dry it and we can make the solution of required grade, which we can again feed to the cell to produce the sodium hydroxide and the chlorine gas. Then the salt separator overflow is 50% of NaOH product containing 2% of NaCl and 0.1 to 0.5% of NaCl, that is hypochlorites, on a dry basis. Then evaporation produces 73% of sodium hydroxide liquor or fused to flake, granular or stick caustic. So at this percentage, the sodium hydroxide will show the higher viscosity. Then we can dry and we can make the flakes, granules or the stick of the caustic. So this the pellets if we are producing, that we can use in a library to form the NaOH solution. Then calcium carbonate used to remove the colloidal ion impurity from the solution. Then NaH3 in countercurrent manner to remove the chloride and the chlorate impurities. So if you see, so pure brine is added. So when pure brine is added, then we have already seen the anode, which is positively charged will attract the chloride ions, whereas the cathode, which is negatively charged, will attract the Na+. So you can see the movement of the chloride and Na+. So here the chloride ions, which is negatively charged, going toward the anode. So anode, they will lose electrons, so they will undergo oxidation process and they will form the chlorine gas, which we can remove from the anode end. Then here Na+, which will go the reduction reaction, whatever the electron lose at the anode, that will be gained by the sodium, and then it is a reaction with the water will produce the NaOH. So NaOH production happens over here, and we can remove the sodium hydroxide from the other end. But in mercury type of cell, we are producing NaG, that is sodium amalgam. So that sodium amalgam is removed from the cathode end. Then we can treat with water to form the sodium hydroxide, and we can get mercury back, that we can feed again to the mercury side. So whatever the pure brine we are feeding, that will deplete in the NaCl, and we have only the water. So that depleted brine we can remove at the later stage, and then we can add more pure brine and the process will continue further. So if you see the mercury process, so it can produce up to 50% of the caustic soda without evaporation, and we get the pure quantity of chlorine gas. If it is the disadvantage of mercury process, then higher voltage than with the diaphragm process, and hence 10 to 15% higher electrical energy consumption. Then more stringent brine purification required in order to remove the impurities and to get the higher concentration of brine, that will lead to the caustic and chlorine formation in the electrolytic cell. Then stringent mercury contamination avoidance is major required. So as we are using the mercury, which is one of the toxic substance, so you have to utmost take care of that mercury contamination in the final product. If you see the diaphragm process, then here we can see the dotted line, it will show the diaphragm by which the movement of ion takes place. So generally this diaphragm is made up of asbestos diaphragm, asbestos. So here we can see the pure brine we are feeding. So the earlier we have discussed the chlorine gas, they will cross the diaphragm and they will go to the anode side, and then Na plus, which is positively charged, they will cross the barrier and they will go to the cathode side. So here you can see the NaOH will go here forming the caustic soda, and here we can get the chlorine as a gas. So chlorine we are removing over here, whatever the hydrogen is produced. So Na will produce, that will react with the water giving H2 and NaOH. So the hydrogen we can remove from this side, and whatever the NaOH which is at a concentrated form, so we can remove as a cell liquor. So whatever the 10 to 12% of NaOH we are producing over here, that can be removed as a cell liquor, and that we can evaporate to produce the higher concentration of the caustic soda. So same way, the utilization of less pure brine in the diaphragm, that becomes the major advantage of the diaphragm or mercury process. Then lower voltage than in mercury process, as we are using the diaphragm. Then disadvantage being the NaOH which are getting is a diluted than the mercury, and also chlorine contaminated, and for that evaporation is required to produce the higher concentration of NaOH. Then Cl2 contains O2. O2 also produced in the electrolysis cells, so Cl2 may be contaminated by the O2. Then rigorous measures you have to require to avoid the asbestos emission. So asbestos also again creates the health problems. They may go in lungs. So we have to always take care while using the asbestos in a diaphragm cells to avoid the contamination and the emission to the atmosphere. Now we will see the membrane process. So here in the membrane cells, a cation exchange membrane separates the anolyte and the catholyte. So brine is fed into anode compartment where Cl2 release and Na plus migrates to cathode through the membrane. So here what happens in diaphragm, we are using the asbestos to separate the two compartments. So in this case, the membrane you are using, which is a cation exchange membrane, that will separate the compartment. So here the anolyte is separated and catholyte is separated in two different compartments. And here the brine is fed into the anode compartment where Cl2 will be released, and whatever the Na plus, that will migrate to the cathode through the membrane. So the membrane is such that it will allow only Na plus to migrate through it. So here, unlike diaphragm, cation ion exchange membrane prevents Cl minus ions to move towards the cathode. So as we have seen, the membrane is cation exchange membrane. So only the Na plus ion that will be allowed to pass through it, whereas Cl minus ions, so both charges will be the same, so they will repel each other, so that will avoid Cl minus ions to go toward the cathode region. So we can get the cathode region product more in pure quantity, and the Cl minus ions will be less over there. And the depleted brine is discharged from anolyte with minimum concentration of NaCl. So anolyte, it will lose the Na plus and the Cl minus, so it will become the very, so depleted brine will become the very low percentage anolyte, so that we can remove, and then we can add the NaCl and we can make it further concentrate, and we can add the it to the again anolyte region. Then water is electrolyzed at cathode, giving strong NaOH. So here the other side Na plus which are going, so we will get the NaOH, and then we can electrolyze water so that we can get more and more quantity of strong NaOH in the catholyte compartment. Then migration of OH minus ion results in the loss of current efficiency. So here the problem with OH minus may result. So when the back migration occurs, it will result in the loss of the current efficiency. Then membrane is the most critical component of the cell technology. Current efficiency, cell voltage, and hence energy consumption greatly depend on its quality. So this is the critical part, because on that the cell efficiency, voltage, and the energy consumption will depend on. In membrane, chloralkali is exposed to chlorine and caustic, hence should have the better qualities. So what happens here, we have the chlorine and the caustic, which is highly corrosive and the caustic in nature. So membrane should be such that it can handle the more corrosive environment and the more caustic environment. So we have to see what the quality should possess by the membrane which are using in the membrane electrolytic cell. So here we should have the membrane should have the good durability, then mechanical strength should be very high, and it should have the long term stability. Then it should be highly selected toward Na plus and K plus minus ion. So it is necessary in order to avoid the Cl minus ions to go in the other compartment. The negligible transport of chloride, the chlorite, and the chlorate ions. So so it should be highly selective so that it can have the negligible transport to the other compartment. Then zero back migration as the OH minus ions, because it will lead to the deficiency or the loss of the electricity. It should have the low electrical resistance, so the electricity will be flowed in without resistance. So if this quantity if we consider, then nowadays we are using the membrane which is a film of perfluorosulfonate polymer, a Teflon reinforcing fabric and a perfluorocarboxylate polymer, and these three are bonded together to form a film, and that we can use as a membrane in the membrane electrolytic cell. Then what are the advantages of membrane processes over the mercury and diaphragm? So the capital investment and the other operating costs are least in this one. Then environmentally far better than diaphragm and the mercury cell. So you can see the asbestos problem over here and the mercury problem over here. But in the membrane you will not have this problem. So it is environmentally more safe to use. Then other cell produces sodium hydroxide 10 to 12%, NaCl 15 to 17%, and need multiple evaporated to get 50% of the solution. But in the case of membrane, we get 30 to 33% only in one stage evaporation for 50%. So here we get the less percentage of the product that need to be evaporated in multiple evaporators to get 50% of the final product. But in case of membrane, at the one step we get 30 to 30%, and in only one stage evaporator we can achieve up to 50%. So as we see the economic wise, so it is far better than the other two. The electrical consumption is also less in the membrane electrolytic cell. So here if we see, so this line represents it's the membrane. So again the compartments are separated by use of the membrane. So we are feeding the pure brine solution in the analyte region. So here we will get the chlorine gas. So anode is positive, Cl minus will be attracted, we will lose the electron and we will get the chlorine gas. Whereas the negative electrode cathode, the Na plus minus ion will be Na plus ion will be attracted, and here by the reaction we get the NaOH. So in this compartment we get the NaOH solution, and in this one we get the Cl2 chlorine gas and the depleted brine solution. So as the membrane is highly selected toward the Na plus, it will allow only Na plus to go inside here and not the Cl minus to pass through it. So we get the NaOH in much purer quantity, and we get up to 30 to 33% of NaOH. And also the electrolysis of the water will also produce the more concentrate of NaOH solution. And whatever the depleted brine we are sending to add this salt, and then we can again feed as a pure brine in this chamber. So here we get the pure NaOH, generated consumption also very less. It's about 77% of that of mercury process. Then no mercury or asbestos used, so environmentally very safe. At the same time NaOH content only 33% by weight. Then Cl2 contains O2. Then very high purity brine required in order to run it. Then present high cost and short lifetime of the membranes. So membrane technology is not so much advanced nowadays. So we can't have the membrane which will possess all the qualities. But the research is going on in order to produce more and more good quality membranes. So once they are done, then this can be removed and we can have the more economical and also environmentally safe process for caustic and the chlorine manufacturing. In this one, major engineering problems are the choice of cell design. So we have seen already diaphragm, mercury and the membrane cell. So all processes are to produce chemicals, but the membrane is found to be very efficient, modern and with low investment, also low electricity consumption. So that we can use for the caustic soda and chlorine manufacturing. Then corrosion is other the major problems because we are producing the chloride. So to handle this one, we can use the stoneware equipment or plastic glass or the rubber line equipment in order to handle the corrosion problem. Also after dyeing with ester sulfur, so ester was also needed to dye chlorine, so that also lead to the corrosion, so that can be handled in mild steel or the iron. Then brine solution as elevated temperature also become highly corrosive, hence we use nickel lined vessels to avoid the nickel vessels to avoid the corrosion to the brine. But at the same time we have to always consider the Fe contamination. Then remainder plant may be of cast iron or steel or the wood. And mercury cells are also made with rubber lined steel in order to take care of the corrosion problem. Then if we see the economics, then if we see the plant location, so we have discussed earlier. So plant location, so if brine solution is the major problem here, so always we have to take care that plant is located near to the brine solution sources, so that we can have brine and we can produce the product in very efficient manner and in economically. Then caustic chlorine hydrogen balance. So the hydrogen, the chlorine which we are getting, we can directly burn with hydrogen to form the HCl. Also we can directly burn the hydrogen, so it won't create a problem for us. Then lime soda process. So this process will not produce the Cl2. So this is the good with respect to the Indian industry, and we can have the other processes of the very good purity and of high quality. Then we have the three different kind of cells. So we have to always go for the choice of electrolytic cells. So if you want the plant to be environmentally safe, then we can have the membrane. So if we can produce the membrane of very good quality, then we can have the choice for the membrane cells. Otherwise, we have to go for the diaphragm or the mercury. So depend upon your capital investment and the quality of product, we can choose the electrolytic cells. And the power cost. As we know, the India, the many states are facing the problem of electricity, and the electrolytic cells, they are mainly depend on the electricity. Also the consumption is also very high in this case. So we have to always take care of the power cost. So we have to find the sources where we can minimize the consumption of power. Also the things which we can produce the power at the same rate. So we can use the diagram for the references, and in next model we will more discuss about the potassium industry.